Welcome you all for today's session, AC characteristics of op-amp. So in the previous session we discussed about the DC characteristics of op-amp. Now we are going to discuss about the AC characteristics of op-amp. As in DC, here also why we are going for AC characteristics. Suppose here the purpose of this circuit is to amplify a small AC input signal such as audio or radio frequency signal. Small AC voltage is applied to the input through a coupling transistor. Such a circuit is useful only as an AC amplifier. So to simplify DC signals, separate operational amplifier circuit is used. So for these small signal sinusoidal applications, the AC characteristics are of two types. One is frequency response and another one is slew rate. So we can calculate the AC characteristics of op-amp by two methods. One is frequency response and another one is slew rate. So what is the need of frequency compensation in practical op-amps, right? So the frequency compensation is needed when large bandwidth and in open loop, closed loop gain is desired, right? So the compensating networks here used to control the phase shift and to enhance and improve the stability of the circuit. So this is the need for frequency compensation in practical op-amps. That is, it needs a large bandwidth and closed loop gain is desired, and networks can be compensated to use the control the phase shift and to improve the stability. Next, what is frequency response and what is slew rate? We can discuss about each method here. So first one is frequency response. An ideal op-amp has infinite bandwidth. An ideal op-amp has an infinite bandwidth. Open loop gain is 90 decibel with DC current, and this gain should remain through audio and radio frequency. Practically, op-amp gain decreases the frequency. So this is due to a capacitive component in the equivalent circuit of an op-amp. So here you can see the graph, the response of frequency response with voltage gain. So this is your x-axis is your frequency response and y-axis is your voltage gain. So here you can see the range of your frequency response, right? So next, slew rate. Why we are going for slew rate? So the slew rate here is defined as the maximum rate of change of output voltage caused by a step input voltage. The slew rate is defined as the maximum rate of change of output voltage caused by a step input voltage. An ideal slew rate is infinite which means that op-amp's output voltage should change instantaneously in response to input step voltage. So this is all about our slew rate. That is nothing but it is defined as the maximum rate of change of output voltage caused by a step input voltage, and in an ideal slew rate is infinite, which means the that op-amp's output voltage should change instantaneously in response in input step voltage. So here the slew rate is defined as the maximum out of change of output voltage caused by the input voltage. It can be specified in V by microsecond. The slew rate denotes that it rises or falls by 1 volts in 1 microseconds. So here the rate at which the voltage across the capacitor dVc by dt is given by dVc by dt is equal to 1 by C. The slew rate S or dVc by dt maximum is equal to I max by C. So for IC 741, I max is equal to 15 microamps and C is equal to capacitor value is 30 picofarad and slew rate here is 0.5 volt by microsecond. So this is all about AC characteristics of ideal op amp. Thank you.